Today's video, we're going to talk about simplification of Kubernetes Ingress. So there's lots of different solutions out there, and if you have to really ask yourself what would really be the right solution for you. And what I wanted to do here was create a video and a demonstration and put a document together with all the configurations that you would need to really make things simple. And so I specifically called this doc Simplifying Kubernetes Ingress using F5 technologies. And this is specifically using F5, and it's really using the best of F5. And so if you're not familiar, here we're going to focus on big IP at the edge. You could almost treat that as like a Kubernetes gateway or a Kubernetes router with edge services. We're going to focus using CIS for automation, and that automation is only specific to allowing all traffic ingress to the Kubernetes cluster. And how CIS is going to do this is by using something called type load balancer based on the specific service. So that is really the simplest way of doing things. It's very similar to cloud-like, where in the cloud, all you do is really require what we call that external IP address. In big IP terms, it's the virtual server IP address that is the external IP to the entire cluster. And that external IP address will handle all traffic for HTTP and all traffic for TLS or 443. And this specifically into this case. What determines that is ultimately the service, which is what I'm going to show you. So in this example, you can see here big IP on the edge. You can see that we're using CIS for automation of big IP. So CIS is plumbed and configured using the APIs to automate big IP. That is done through the Kubernetes API. And CIS will communicate with F5 IPAM, which is also think of it as a kind of child-parent relationship between CIS and the F5 IPAM controller that lives in Kubernetes. What the F5 IPAM controller is monitoring is it's monitoring the service. And so what this allows us to do is pull an IP address out of the range, or pull an IP address that's specified in the IPAM controller and assign it to that specific service, and then keep track of it so that that specific service always has that IP address. So that's where we get the external IP from. In this environment, we get the external IP address from the IPAM controller, which is a configured range. I'm going to go ahead and show you all of this demo and kind of how it works. And this is ultimately, by using these components, you're really simplifying Kubernetes Ingress. The other thing is that these components in this architecture are 100% supported by F5. So you can call in, open a ticket. You can ask to talk to product management, either on the F5 side or on the NGINX side. F5 technologies 100% supported. So everything you see here is off the shelf. You can use it today. So again, the purpose of this document is to demonstrate Kubernetes Ingress using F5, Big IP, and NGINX technologies. This user guide simplifies the solution by providing an example and a step-by-step approach. Step-by-step guidance. Clone my repo, pull my repo. You'll be successful in doing this. You might ask why F5 technologies? Well, F5 Ingress solution is really providing you with the modern container application workload. That's really important. It's modernized container application workloads. This is going to scale really well. We're using both Big IP container ingress services as well as the NGINX ingress controller service for Kubernetes. Highly recommended to use NGINX Plus. That's the image that you want to install. It's really an elegant control plane solution that offers both working with different personas and different technology groups in almost a single instance, a single interface. That is the interface of type load balancer. That is the service. That's where the magic happens. And it's really offering the best of breed from what F5 can offer using both Big IP and NGINX, which is fostering the collaboration really between the two different groups, between the NetOps and the DevOps groups. So you've really got the relationships between NetOps teams that manage the Big IP and the DevOps teams that manages potentially the Kubernetes cluster or the specific services, in this case, Coffee and Tea. Coffee and Tea are the services that are configured. All the routing between Coffee and Tea is going to happen here. Big IP is going to ingress all traffic to this cluster of NGINX Ingress controllers, and all of the routing is going to happen there. So all of your DevOps communication can happen independently of the Big IP, and all that the DevOps user's got to do is set the service type load balancer tag and make sure that the IPAM is there. So let's get into that a little bit more. And so obviously the first thing that we would need to do in this architecture would be to obviously enable CIS. This is everything you need to do to configure CIS. To create the cluster role bindings, provide the username and password, CIS needs to talk to Big IP, create and deploy the cluster role bindings so CIS has permissions within the Kubernetes network. We are using CRDs, so CIS as well as NGINX, you would need to deploy the CRD. I have put the latest CRD files in here. You can literally just clone and deploy them. As you can see here, there is the repo. So now that you've got CIS ready, there's a few arguments that we need. So CIS does have a manifest file. It does need a few arguments. The first thing is CIS needs the custom resource mode, or CRDs is true. We are using on CIS namespace NGINX Ingress. CIS is isolated in this case to only watch that namespace. CIS can watch additional namespaces. CIS can load balance other types of services, but in this instance we are specifically isolated. We are only monitoring NGINX Ingress by applying this statement, and so we're only really looking at that namespace. We are integrated using a flannel type VXLAN CNI, so we are doing cluster IP. CIS will provide all the information to Big IP for Big IP to communicate directly with the NGINX Ingress controller pod itself. So it's Big IP directly to pod, and that will all be provided by CIS. All that you would need to do is set up the VXLAN network. I've got lots of demos, lots of videos on creating VXLAN tunnels. If you need help, reach out to me. I can help you with that. Because we are using IPAM to provide CIS with the public IP address for that service, we need to enable IPAM is equal to true. So here is the repo. Create the CIS deployment, and then you can always view CIS deployment with using kubectl get pods -n kube-system, because that's where we are deploying it. CIS does need to create this thing called a dummy node. This is so that CIS can participate in the OVN Kubernetes network from a cluster IP. So CIS kind of treats Big IP as kind of like an external node, and that's how we're able to route traffic. It's really important that you follow that. Again, if you need help, please reach out to me. There are lots of existing and really good documentation, but really at the end of the day, you just need to clone this. Provide your specific IP address and your MAC address of the Big IP for the tunnel. So once CIS is deployed, the next option at this case would be to deploy the IPAM controller. This is really step 2. So the IPAM controller, as you can see, is range based, right? So there's an IP range. In this case, I am using the IP range of test. Test is an IPAM label. So think of this as a label that we're going to specify to determine that this service can be, this service is from the, if you want to call it, test range or test network. So what will happen is IPAM will assign an IP address from this pool. This is a small pool, but just because a demo example, I really only need one address. This is the first address. This is most likely the first address that's going to get assigned. I'm logging debug here. Recommend you change that if you need. The persistent volume is really important. You are required to create a persistent volume now with IPAM, and the reason is if you restart the IPAM controller, we need to persist the IPs to labels. And so that's what this persistent volume is doing. Again, copy my files. This is a working example. Make sure that you specify where you want to create the persistent volume. I just use node 1 in this case. This is where I'm creating the volume. That's really all you have to do at this point, is just really specify the value in this case. And again, it's in the repo. At that point, go ahead and create your IPAM controller. And once you've created your IPAM controller, you can log the IPAM controller. Let's take a look at what that looks like. So you can see here, I am logging the IPAM controller. You can kind of see the IPAM controller is starting. This is the version that it's running on. You can see here creating IPAM, and it's monitoring the following namespace. You can see the clients. You can kind of see here where it has started storing these addresses, IP address status. You can kind of see here, this is kind of where it stored this before, but there are some addresses here that it's kind of allocated a little bit. And then there's just some kind of debug logs. You can see that I had requested and allocated one before, but my last thing that I did here is I deleted this service that was bound to that IPAM label to that IP address. You can see the operation delete. So we will create that again, and then we will monitor the IPAM controller. So that's how I know that the IPAM controller is running. I am monitoring the logs. You can look at these logs. If it doesn't start and you need to troubleshoot, it could be a permissions issue. And cluster role bindings, the cluster role bindings are so important when it comes to this file here. Is very important that you get this right. And that's why I provided you a working example in this GitHub repo. Step number 3 is now to create the NGINX controller piece. Now I've provided an example here. I'm using OSS. It's recommended to use NGINX Plus. Work with your account team to get or build that image so that when you deploy your CIS controller, then you would use your NGINX Plus image that you can get. And that's why you would, the reason why you would do that is so that it's not community supported. So because we're using CRDs, if you can just pull down the following file to get these repos, just go down here and just pull down these files. These are the CRD files that you need. Create the namespace and the service account. The NGINX role-based, it requires your default cert, your NGINX config. I am not using proxy protocol at this time. CIS will get proxy protocol in 2.7, which is the next big release, when we add our policy CRDs. And our policy CRDs, you'll be able to create the iRule. So at this time, there's no proxy protocol. I will update this diagram. I'll update this example once 2.7 releases with the policy CRD on the CIS side. So really important, if you look at the nginx-config, there's no proxy protocol at this time enabled. And so here's really where the most important deployment comes. So when you're creating the NGINX service. So let's take a look at this NGINX service. So what you will notice, this is a very simple standard NGINX service. I am exposing port 80 and port 443. There's a couple other things we can do here. We can add a health monitor. We can add the monitor for CIS to check on NGINX. It's the liveness probe, if you want to call it. That's listening on 8081. We can do all that. I just wanted to keep this real simple. So in this instance, I didn't do that. We're using type load balancer, and that is the service that and the application called NGINX Ingress. But you will notice this annotation. This annotation is all you need for CIS to plumb the big IP. All you need here is this label here, this IPAM label of test. And if you remember, when we created the IPAM controller, inside the IPAM controller's arguments was that IP range is equal to test, and test had the IP address range. So when we create the service, we will automatically plumb the big IP. We will get the IP from, if we go back to the diagram, we will get the IP address, if you can actually see it right here. CIS will actually get this IP address from the IPAM controller, and the IPAM controller will get that information but once the service is created. So let's go ahead and do this. Let's go on to our big IP and take a look at our big IP right here. You can see I'm in the Kubernetes partition. There's no examples. You can see my example.com, everything filled right here. So let's go on to the Kubernetes and do kubectl create NSF NGINX, and what we want is we want NGINX service. So we'll go ahead and we'll create this. You can see on big IP here the examples right there. So you can see that the virtual was published right there. Virtual was published. And so if I go look at the pool member, you can see that there's one pool member there. And that one pool member is the one NGINX instance that's running here. If I go and call that, do a kubectl get the pod for the NGINX, you can see that that's the pod right there. And let's do a kubectl describe the pod, and the pod that we want to describe is this pod right here. We want to describe this pod -n NGINX-ingress. So you can see we've described this pod. This kind of talks a little bit about the pod, but if you notice that the pod IP is the same. So that's the same as what's on big IP, and that's the same as the pod IP, and we can connect to this. We can connect to the service. There's coffee, and I can connect to tea. As you can see, I'm connecting to, you can see that is the remote IP. That IP address there is the same as the service. It's the remote IP. You can see on my real IP, this is coming from the self IP on the big IP itself. And you can see the different endpoints that I'm going to over there. These are the different pods in the pod network. So that would obviously be the last step, is to create the pods themselves. So as you can see, we kind of cut corners a little bit there. We created the pod, but if you go back and look here, we actually, after we deploy the service, we can go ahead and deploy the service, then go ahead and deploy the cafe application. The cafe application is pretty simple. Just run these 3 commands. You can deploy the cafe application, and that will deploy the application. To test this, what we did was we ran and we checked the virtual IP, and then we connected to the coffee app and the tea app. So let's go ahead and recap. So this demo really shows the simplification of Kubernetes Ingress using the F5 technologies, and it's really the better together solution with using type load balancer with big IP and NGINX using CIS and F5 IPAM. And as you can see, what happened is once we created the service with type OB, IP address was allocated, and then it was provided and plumbed to the big IP. Thank you very much. If you like this video, then go ahead, like, always helps, to subscribe. If you request or want to see more videos, please let me know what you'd like to see, so that I can go ahead and create the examples and have them published. Thank you. Have a good day.